Is it good? And scene. All right. All right, finally. Sorry about that for the delay. So for anybody who might be listening online, I know everybody here knows me. My name is Jesse Altman. I work for a company called financialforce.com. We build a bunch of products on the AppExchange. I, in particular, am the HCM Architecture Lead, so I work on our human capital management product. I work with a Scrum team every day that's in England, but I also help work with other development teams that are working on the product in Spain and India, and also work with the management team in Canada. So I'm kind of all over the place. So today I want to talk to you guys about the Stub API and how that works with ApexMocks, and how you might want to utilize the Stub API, or how you might want to use ApexMocks. This is a presentation that was actually done at Dreamforce this year, and I want to give a shout out to my two co-presenters who were there. And though they're not speaking today, they helped build the slides, and they're both really, really good at what they do. So David Frudd, he's a senior software engineer with me at Financial Force. He works on our platform team, and he's actually one of the key contributors to ApexMocks. So as I get more into it, and you know, if anyone who's familiar with it, you might recognize things like matchers and stuff like that. All of that new functionality is actually stuff David's worked on. And then John Lean, who's a lead software engineer for Salesforce. John is the main author of the Stub API. He's the kind of the brain behind all of this, and he's the one who's trying to make mocking on the Salesforce platform a lot easier. So hopefully as I go through this, you'll get a bit inspired and be able to either create your own mocking framework or decide to use ApexMocks. So a couple quick things, forward-looking statements. There's a bunch of stuff in here that's not out yet. Don't purchase anything based on that. So we're going to talk about the Stub API first and its use in mocking frameworks. So I want to kick right into an example. So this is Java code that's written with Mockito. And you'll see that at the top, you know, we're going to create a mock, and just creating a mock of counter. And you'll know that it's, in particular, it's really important that it's creating a mock of the counter class, and it actually instantiates it directly as a counter class. So it's not an implementation of it, it's the actual class. You have a when call, so you're basically setting up a recording of when this method's called, then return this value. You have a simple assert statement, and then you have a verify call that works very similar to how an assert statement would work. It's basically verifying that your next method is called. Now let's compare this to something like ApexMocks and how this would work there. So the main difference you're going to note right off the top is the difference in how a mock is created. So you'll notice that we're actually casting it to an interface. And instead of instantiating a mock of a particular class, we're actually instantiating a class that's in the system. And even though we're calling it mock counter, it's a class that we actively have to maintain in one way or another. So this is actual code that's going to live in your code base that's purely used for mocking. And then as we kind of go through, the rest of it's relatively similar. You can do your when to log a call and return a specific amount. You have your normal assert statement, and then you have your verify call. So the main problem here, as I called out already, is that this class can't be defined at runtime. Before this code can even be written, you have to set up this mock counter implementation. In ApexMocks in particular, it actually is generated code, so you'll use a Java jar file as part of your build process to generate like a mocks class, which contains implementations of all of your interfaces. It does need to be regenerated every time something changes, so it is a requirement if you're going to change basically your interface definition of like a service, for instance. You would have to regenerate your mocks class after making that change. It has to be packaged and deployed, so it kind of bloats your code base. For however many mocks you're going to use, you're going to have exactly the same amount of mock classes that you need in your system.
Is that all the way through into a managed package as well too?
Correct, yes. Even in a managed package, you have to include all this code because it's part of your unit test. Now they are annotated is test, so there's a little things there, but it is just normal Apex code, and that's basically a big limitation that ApexMocks and anyone who's using ApexMocks has to kind of work around currently. So how does Mockito avoid issues like that? Well, the first thing they do is they're not actually creating real code of the class. What they're doing is creating anonymous instances of the class using reflection. So it basically looks at your counter class and says, what methods do I have on that class? And then generates an anonymous instance of that class with each of those methods overridden, so that you can kind of call them and log all of your functions as you go. So the solution to all of this, and to get the Stub or any mocking framework on Apex closer to something like Mockito, is to use the Stub API. So the Stub API is very simple. It is exactly what you see on the screen. It's a single method, and it's test.createStub. And what you do is you'll pass a type to it. So this will be your type of your class, and a stub provider, which I'll go into in a little bit more detail. But what this is going to do is it's going to create basically an anonymous subclass of the type you're passing to it. And it does a couple really cool things that I'll go into here. So the second argument is that stub provider. And what the stub provider does is it basically handles all of your method calls on your stub. So for instance, if the example we were looking at had a next method, the way this would work is on your stub class, it would use this stub provider, so that when you call that next, it will call into this handle method call. And from there, you can do any logic that you want. So you'd have your Apex class. You would have this mocked class with your methods on it. And that mocked class would call into your stub methods handle method call. And there you'll see that you pass in like the object, the method name, and a return, a bunch of parameters. And basically the way it works is when you have a certain list of parameters, it'll return whatever method or whatever type you're passing to it. And that comes back right into your Apex test. So how might you actually implement your own mocking framework? Here's an example that John came up with. And it's similar to ApexMocks. But it's very simple. So essentially what you do is you'll have a class like sample mock framework. That class needs to implement your stub provider. And then you need a method like mock, which will call into the Stub API. And what this does is it basically just returns an instance of this sample mock framework for you to then be able to call when and handle method calls to essentially do whatever you want. There's whatever logic you want to add in there to do any amount of things is up to the developer of that framework. So let's take a look at an example kind of in practice and how this might work. So we have our counter class here. It's relatively simple, but notice that it's just a normal class. It's not implementing any interface. It's not virtual, anything like that. And what you'll see is when you call into the test.createStub with the counter type, this is the code that will essentially be returned to you. So this is your anonymous class that gets generated. And you'll note that it's actually extending counter, and it's setting up your next and your skip with your stub provider with calling into the handle method call. And it's really kind of cool how this works, because you don't need things to be virtual to be able to extend them with this functionality. So you can basically, it'll override all visible non-static methods. So visible, you're talking about public methods here on your class. It only works within your namespace, and it only applies stubs. So this is all kind of just test code. And it's the ability to kind of override those non-virtual methods is kind of Apex exclusive. So with all of that said, and you might be getting a little excited now, there are some restrictions that still apply. The biggest one is the fact that you have to have a default constructor. So you need a zero argument public constructor, essentially. It can't be private. It can't have a constructor with just arguments. You have to have a public zero-arg constructor. You can't mock properties. So one of the big features, I guess, in like a controller in Visualforce or in Apex even, is the fact that you can put kind of logic in your properties. None of that can be mocked out currently with the Stub API. There's also some limitations around what your return types can be. So you can't return like an iterator is a good example. With all that said, John has been working really hard on all of this, and I know they plan on continually improving these new developer tools they're kind of providing us. So I would be very surprised if this stuff wasn't routinely kind of knocked off this list, and as the Stub API is made more robust. So it's important to understand that the Stub API and what we're talking about here isn't a mocking framework. So unless you're creating your own mocking framework, you'll probably never have to know anything about this or even want to use it. What this is it's a low-level API built specifically for somebody who's looking to make a mocking framework. So one of the more known mocking frameworks on Salesforce currently is ApexMocks. However, it's important to note ApexMocks is basically mimicked off of Mockito. You know, a lot of us are old Java developers, and Mockito is just something we're all very familiar with. However, if you're more familiar with a different mocking framework that might have way different syntax or different functionality, the Stub API is going to open up the means to create your own mocking framework and make things much easier to kind of get into and use. So how do you get it if you want to start using and creating your own mocking framework? Well, it's pilot in winter 17. It's basically something that not a ton of people are going to be using. So if you're really interested in it, I'm sure you can get access. And it should hopefully be generally available spring 17. Note that both of these are forward-looking statements, so let's not make any assumptions. We're not sure when it will go generally available. With all that said, you can use ApexMocks currently. It doesn't require this functionality, but it is a lot nicer, and I'll show you why in a minute. So at this point, I want to take a step back and talk about what ApexMocks is, what mocking frameworks are, and why you might want to use something like this. So first off, what's ApexMocks? Well, it's open source for one. This is a framework that's entirely available on GitHub. You can use it in any product, it can be commercial, it can be anything you're doing for fun. You can basically do whatever you want with it. The only thing you're not allowed to do is take an exact replica of it and try to sell it. I don't know why you'd ever want to do that. No one's going to pay you for it, but you can't do that. It was built entirely in Apex by other Salesforce developers. So these are people who have been working on the Salesforce platform, writing Apex for years, and it's just something to trying to kind of build the platform up. As I mentioned already, it's very Mockito-like, so you'll see kind of what I'm talking about in a minute here. And it was originally developed by a guy named Paul Hardiker at Financial Force. So what's the benefit of using ApexMocks, or really just a mocking framework in particular? Well, the first thing is it's much easier when you have a mocking framework in place. One of the big problems in Salesforce when you're trying to write your unit tests is the fact that you have, you typically have very excessive data setup that you have to do. The more complicated the org, the more objects you need to insert, the more records you need to be able to fully test things. And then you'll have those records when they get inserted in the data layer, they're doing things, be it workflow rules or triggers or validation. And before you know it, you have this very complex web of tightly nested data that is all dependent on each other. And if one little thing breaks, all of your unit tests start breaking, all that stuff. So by using a mocking framework, you can remove the need to kind of hit the data layer almost entirely. You can basically mock out all of the calls that might essentially hit the database and make things much easier to kind of run through without actually inserting any of this. That also kind of builds into my next point, is that will make it much faster. So one of the slowest running processes whenever you're talking about web development is interacting with the data layer. By removing the need to insert this data, it makes things faster. On top of that, it's also going to remove any kind of complex, slower running business logic that might be integrated closer towards, whatever your code is calling. So say you're writing a unit test for a controller, for instance, and that controller calls a service. You don't necessarily want or care about what that service is doing. You just want your code to be able to run through as quick as possible and test just that isolated piece. By using mocking, it's much easier to do that. That builds into the fact that it makes it much stronger as well. So as products on Salesforce continue to get more and more complex, and I'm sure everyone here is very aware of this, things can become very tightly integrated. And when you're testing maybe you're testing a small method that calls maybe only a single service method, you don't necessarily control what that other service method is doing. And that service method might call into a bunch of other classes, or it might do DML and whatever. And if you're writing your unit test against that currently, things might go really haywire if a colleague comes along in the future and then changes something on that service. They don't necessarily know that your code is dependent on it, and all of a sudden, unit tests are broken in an unexpected way because now your code is very tightly dependent. By removing that and isolating each individual piece of code, you're making everything much more reliable and being able to run it much faster and stronger. And finally, all this kind of builds into the fact that we're trying to get closer to TDD, or test-driven development. We're all aware that what we kind of do currently is integration tests, not really unit tests. And hopefully, as we continue to work on the ApexMocks and invest in these types of technology, we'll get closer towards that TDD environment that we're all shooting for. So let's take a look at ApexMocks in action. So we have this very simple method. We'll just assume this is on a controller, and it's on calculate, and it calls into your service to calculate their value. And you write your unit test. Pretty standard. You're going to create some data. You're going to instantiate your controller. You'll set your data on that controller, and then you'll call your onCalculate method. As I'm sure you're all aware, we have no clue if this will pass or fail currently. The main issue is we have our opportunity service, and we have no clue what calculate value does. It might seem like it'll work because I set value 1 and value 2, but maybe calculate value just returns 4 all the time, or maybe it could do literally anything. So how do we solve the problem of us not knowing what opportunity service does and make our test isolated from that functionality? Well, we need to rewrite this unit test using ApexMocks. So the first thing we're going to do is we're going to instantiate our mocks, our fflib ApexMocks class. This is kind of the brain behind the entire mocking framework. It's going to hold all of our stored method calls, all of our stored return values, all of our stored parameters, everything, so that it kind of controls everything that's going to happen here. The next thing we do is we instantiate a mock service. So this part is really important, and this is the main part that we're changing with the addition of the Stub API. So you'll notice here that it's actually mocks.opportunityService. So what we're doing here is this mocks class is actually what gets generated from that Java jar file. And what it does is it runs over your opportunity service interface and creates an entire fake class that you then include. I'll show you in a bit how we're going to change this, but it's important to recognize the fact that you do need to have that mocks class in your system for this to work. The next thing we're going to do is we're going to set up our stubs. So we need an opportunity, so we're just going to generate a fake opportunity. It doesn't need anything on it because we don't care what's actually on it. All we need is an instance of an object. And then we get into the cool part. So we're going to call mocks.startStubbing. And what this does is it tells the system, hey, I don't want to actually call this method on my mock service. What I want to do is I want to record the method name in conjunction with the parameters so that I can have a specific value that gets returned. So the way to look at this and the way to read this is when mock services calculate values method is called with the specific parameter of single op, then return 30. And this is all getting recorded on our mocks object, which you remember links back to our fflib ApexMocks class as an instance. We're then going to stop stubbing and get into our actual code. So this final line I want to call out, but I don't want to get into too much here. So what this is doing is it's utilizing the Apex Enterprise patterns. So for anyone who's not familiar with Apex Enterprise patterns, or you might have called it Apex Lib, it's essentially a way to do separation of concerns on Apex. If you're not familiar with it, I definitely recommend checking it out. Andy Fawcett has a bunch of great articles on it. But the way it works is you kind of use your application class as a dependency injector. So what this is doing is it's going to override our opportunity service.api instance with our mock service. And this will play back into our opportunity service.calculate value call and replace that instance with mock service rather than opportunity service.api. So hopefully that makes sense. If it doesn't, it's a little bit more complicated, but that's all related to Apex Lib. Finally, we're going to finish out our test. This part is all very familiar. We're going to instantiate our controller. We're going to set the opportunity on that controller, and then we're going to call our method. And at this point, we can guarantee that our assert method or assert call will pass, because we know when mock services calculate value method with single op is called, it simply returns 30. So some supported features on ApexMocks, when returned, so you just saw this example. There are some overloaded versions of this. Oh, sorry. So we have when throw as well. So this is similar to when return, but instead of returning a value when that method and that parameter combination are called, this will throw a particular exception. This is really, really useful for error handling testing. So I'm sure you guys have all tried a written unit test before where you're trying to do things correctly and you have try catch blocks, but sometimes you don't have a particular case where you're trying to get into the catch scenario. You might just be catching like an exception that might happen and logging it out or something. This makes it much easier to kind of force that error condition and make it so that you can get and test that piece of code. We also have a verify call, so think of this like an assert statement. The way this works is it's going to assert that mock services calculate value method is called with the parameter of single op. If mock services calculate value isn't called with that parameter, it'll actually throw an assert exception. Now this method does have overloaded values, and you can specify multiple calls. So this asserts that it happens exactly 2 times. If it happens 3 or more, it will throw an assert exception. And we have some constants. This is the same method, but it uses the constant for never. This asserts that this method was never called. This could be really useful if you're trying to test, like an error condition is a good example, where you want to make sure that a piece of code doesn't get hit because the code went a different route. Other great supported features that are relatively new, and this is stuff that Dave was working on, are captors. So this is all, captors work more around eventing. So if you're familiar with how that works, you can read up on some of that. Matchers. Matchers are basically ways to do generic parameters, for instance. So all the examples I've shown so far is when we call calculate value with that specific parameter of single op. A matcher would work where you'd say, okay, I want to call this service's method, but it could be any object I pass to it. It actually allows you to call a method called any object and makes it so that you can set up your stubs much easier. Final method, or final thing I want to call out is the ID generator. So this actually isn't new. It's been in the system for a long time. But it's a question that has been brought up to me several times when I've talked about ApexMocks. One of the problems and one of the challenges you'll face is that there is functionality that you'll need sometimes where you want an ID on an object. And as you guys all know, if you're not inserting the record into the data layer, you're not getting an ID set. So what this does is we have a single method that you call, that you pass the object type to, and it just returns a random ID for you based on that object. So as you guys know, that if you break the ID apart, there's pieces of the ID that relate to each thing. It essentially returns a valid ID for that object type. And it's a way for you to set up relationships and things like that so that your test can run through properly without actually having to insert those records into the data layer. So everything we've looked at has been without the Stub API. This is all stuff that's currently available. It requires interfaces, and it requires that mocks class that I talked about. That is a very big challenge, and it's something that unfortunately does turn a lot of people away because it requires a different architecture to basically your entire application to be able to fully utilize this. With all that said, the Stub API is going to make life way, way easier. So let's just jump right into that. So the current implementation works a bit like this, and don't miss out on the symbolism here of the pyramid. You have your application code, but your foundation is really your test. So the way this works is you have your application code, and then you have your test code for that. Your test code will call into ApexMocks, which utilizes generated stubs, which happen from your ApexMocks generator. The ApexMocks generator uses an interface mocks properties file to basically map your interface names to new mock class names. And the mock generator has to be run before any of your test code can be utilized. The way the generated code looks is something like this. So you basically get your mocks class, and you'll see this has an opportunity service in it, and it implements your interface. And then it just sets up this fake method with the call to mock non-void method. And you'll notice it actually looks relatively similar to the handle method call of the sub provider. And it does actually work very similar. The downside is all of this code has to be included in your code base. So what is it going to look like when you use the Stub API? You'll notice it all of a sudden became much simpler. We don't have this outside force anymore. There's nothing that's off the platform that's required. You have your application code, and then you have your test code, which will call into ApexMocks, which then calls into anonymous stubs. This is really powerful because it doesn't require you to have the complicated dependency injection set up. It doesn't require you to have everything implemented with interfaces. It doesn't require you to have a more complicated build process to generate these classes, to then package these classes. All of this happens at runtime on Salesforce. So it makes things a lot simpler. So how did we go about changing ApexMocks to use the Stub API? Well, the first thing we had to do is change our ApexMocks class, which, as you remember, kind of drives everything, to implement our stub provider. Pretty simple one-line change. And then we added a couple new methods to our ApexMocks class. First was the factory. So that is what's going to call into our test.create stub. It's just going to be passing the stub provider, which is the class itself, and whatever your type of your target class is. We also have this new handle method call, which is going to essentially just call into mock non-void method, which is what our previously generated code used to call. So what do we have? 10 lines here, 1 line there, and that's that. It's an 11-line change that we had to do to be able to use the new Stub API. So I know what you're thinking, all that sounds great, but maybe I'm using ApexMocks already. Don't worry about it. ApexMocks is backwards compatible with the changes that we've made. So if you want to continue using your current implementation and you're not looking to use this new factory method with the new call out to handle method call, that's fine. You can keep using what you want. With all that said, it's still probably a good idea to consider using this new functionality once it becomes generally available, because it will make things a bit easier to kind of work with. So what's it going to take to actually switch your tests to use this new functionality? It's basically one-line change. You need to change your mock call. So instead of instantiating a mock class, you just call into the factory method with that class type. Now, the really important distinction here, and you might have missed it at first glance, is the fact that we're not actually casting this to the interface. We're casting it as a type opportunity service. That's really, really powerful because it removes that dependency of doing your interface calls with your dependency injection. So as I mentioned before, you need to make sure all the classes you want to mock have a specific zero argument constructor. So there's a couple here that work. Your implicit, so if you don't have any constructors at all, it has your default public zero argument constructor. You can make it explicit public. You can make it global. However, you can't make it private, even if you open it in test visible. It is a downside, but unfortunately it doesn't work. And you also can't use just a single public argument or a public constructor with arguments. I have been told that the plan is to remove this limitation, but we'll have to see. So how do you get around that? A good example for anyone who's familiar with Apex Libs is the domain layer. So domain layer is basically specific to objects. So you have a class for each object type. And the way it works is you always want your constructor to pass a list of objects into it, because it is essentially controlling your data layer, and you want everything bulkified. So the way we have gotten around this to start using this to test is we just create a new public zero argument constructor, and we call into the previous constructor, and we then assert that it's running the test. If it's not running your test, then you fail. Your code won't actually work. So this prevents developers from using this new zero argument constructor and accidentally running code that they shouldn't in a actual production environment. And is that it? Yeah, that's basically it. You know, it sounds pretty simple, it sounds pretty straightforward, but it's actually really powerful. You know, the big deal here is that it makes the developer experience much better. You know, the hurdle of actually having to generate that code and use something like Apex Lib is very large for anyone who's not necessarily like building a product or doing some on-site work. If you have any sort of timetable that you're set against, that you don't necessarily have that investment time up front, it becomes very hard to argue that you need this investment. It's also providing a lot more flexibility. So ApexMocks had a lot of limitations in that it was all written in Apex and it needed to work like normal Apex code. By removing that, we're going to be able to do a lot new cool stuff, like mocking non-virtual classes, abstract classes, or classes implementing multiple interfaces, which ApexMocks doesn't currently support. There's also a whole lot of new enhancements we're going to be looking to make, such as spying, partial mocks, auto mocks, and automatic dependency injection, and more. So there's a couple of resources for this. So you can check out the Stub API. It's in the release notes for Winter 17. And for ApexMocks, there's a ton of articles, and the GitHub link is there. If you do get access to the Stub API pilot and you want to try ApexMocks out, the Stub API branch is out on GitHub. You can pull all that code down and run it as well. And then there's a bunch of blogs here which have all ApexMocks articles on there and how to use it, how to get started, and stuff like that. And with that, thank you. Anybody have any questions?
Can you knock out any system classes, or is it all just user?
That's a good question. So for anyone online, the question was, can you mock out system classes, or is it only user-created classes, or basically developer classes? As far as I know, you can't mock system classes currently. Okay. I don't know if that limitation will be lifted. Maybe, but I think they will have good arguments to say maybe not too. So we'll have to see. Any other questions? All right, great. Thanks, guys. And the crowd explodes.